Who's got their calculators? It's not bad. It'll just sit. It's real simple. Go to mode, go to polar, and type it in. I want you to see the curve form. Oh, it will look really small. So when you hit zoom, trig, hit the zoom button, hit zoom, trig, it makes a really good image. And you can trace it out. You can trace it out. Okay? I mean, real simple. It's even something you go, display this. I go, oh, I don't have to display that. Because I know you could do it very easily. You go to mode, hit put out in polar. Type in 2 sine 3 theta, and then hit zoom trig. It makes these nice petals that form. Because there's more petals, aren't there? Where's the petal after here? I'll borrow Andrew's calculator. Oh, he put it in there? You're good. Oh, and we got another one over there. It went over in third quadrant. Thank you so much. So the next petal in here, I didn't even write it down, but the next one goes, goes, woo, and you get a third petal. But then it repeats the pattern. So please, I encourage you to use the technology to help support you, because some of these have like 8 petals, right? Woo, 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 woo. You follow? What is most important? What is most important, everyone, is that you can make one loop. So what were the limits that made one loop? That's going to be important for tomorrow. I'm going to shade it in here. What were the limits that made one loop? I think shade in here helps. See the half semicircle looking thing right here? From here to here, put this in your notes, made the one loop. Because tomorrow they're going to go, find the area of one loop. And you're going to be like, this is easy, except what are my limits of integration? There's your limits of integration. So that's what I mean. It's important that you could go through to figure out what forms that one loop, the limits of integration. Hey, the last problem that we're going to do, I thought I'd give you an image like this. And I was wondering if you could create the polar curve. Okay? Now this one, you asked me which one this was like. This one was like number 35, right here. This last one, the last problem, this is like number 47. And it goes quick. I'm going to give you an image like this. I want you to help me make the polar curve. Okay? Oh, go ahead, Nicholas. Where did that third come? This came from calculator. I didn't plot it. Very good. But it would be if we continued this process. Because I went out to here, right? And then made 2 petals. I wanted you to see, sometimes it's hard to see how many more petals you're going to get. I would have just done another one. Nick, I would have done 2 more points here. You can just follow the pattern, right? This was a 4 pi over 6, 5 pi over 6, 6 pi over 6. And then what you would have saw is 6 pi over 6. This will return to 0, but this would just pop it back at its 6. Isn't that cool? So good question. I just didn't draw it there. So feel free to use the calculator if you want for support. I love it. Nick wanted to see where was that third loop. Hey, can I erase? Okay. Why is it? And I want you to sketch the polar curve. But I'm going to give you a graph representing the relationship in Cartesian coordinates. All right, here it is. I made this one up. But it's good. This is like number 47. Okay. Last problem. This is theta. This is r. Okay, I had a point here at 1. I used pi over 2, pi, 3 pi over 2, and 2 pi. I started here, I went up to here, I came back to here, down to here, and right there. So here's my key points on this curve, and I'll highlight in yellow. Here, here, here. This is theta, this is r. This is graph representing the relationship in Cartesian coordinates between r and theta. Can you sketch the polar curve? The challenge is, everyone, we don't know the equation. Now what's neat is, I know a lot of you can do this in this class. If you know what that equation is, you could brainstorm and put in your calculator. Does anybody recognize that as a sine or cosine curve? Okay, good, good. But I'm going to pretend like, hey, I didn't know that. So I'm going to treat this isn't going to be hard. I say start with making a table. Help me make a table. What's going on at these key points? Start with, what's going on when theta was 0? What's the radius? 1? Oh, I should label these. This is a 1, this is a 2. This is 0. All right, what's going on at power 2? How high is it? 2. How about pi?
1.
How about 3 power 2?
0.
And one more point, let's go on 2 pi.
1.
Help. So first thing I did, everyone, I made a table. This isn't hard. I just wanted to show you that we can just go ahead and make a table here. Oh, some people are still copying this, so we can get this. But to do this problem, this is like number 47 from the textbook. Let's make a table and then we'll just start plotting this. Like those little curve around in terms of sketching a polar curve. Cool. Kind of always get that. The key is, once you look at this, extract the most important points. The highs and the lows, the max and the mids. You ready to sketch this with me? All right, we're going to go one at a time to sketch this thing. This is going to be in polar coordinates. It's the same Cartesian plane, but we're sketching the polar curve that represents these points, okay? All right, start here. What's theta? Where's theta 0? How far away am I from the pole? So go 1 away from the pole. All right, so I'll start right here. Now, this curve is going to continue, move to the next point. Where's power 2? How far away from the pole will I be? So what I need you to do, go 2 tick marks up here to 2. I need you to connect this point to that point, and you can just use a curve that just curves it. I'm going to check these off as I move, because everyone so far I'm moving counterclockwise. All right, now where's the next point? Pi, where's pi? Here, and how far away from the pole will I be? So I'm going to put that point, but I need to connect this point to that point like it's a curve. Make sure it's symmetrical. Oh, here's -1, or in x and y's, but it's a what? It's a 1 for polar, so I won't even write a number here so you don't get confused. I'm 1 away from here though, right? Now, where's this? When I get the 3 power 2, I'm going to connect a curve. I'm going to get how far from the pole? So this is going to sneak in here like this. Did everyone see that? I am now 0 away from the pole. Oh, I'm on the pole. You follow me? I had to connect this point, it's a curve, to this point. Now, one last thing, because you'll see symmetry. To finish out this curve, I got to go from here to here. What's going on when it's at 2 pi? How far away from the pole will it be? And what does it look like? They call this a cardioid. They call this a cardioid. It makes a cardio. It looks like a heart, like an upside down heart. Now, who recognized that from trigonometry? All right, what curve is that? But what did it do? All right, so what could you type in your calculator right now just to check this? R equal to sine of theta plus 1. If anybody wants to do it, you should get the cardioid. I just wanted you to see that. Sometimes it's helpful if you recognize the one I invent, you know, like on a test. I invent a curve like this. If you can recognize what it is, you can do it that way. Hey, everyone, super job today. Tomorrow we do 10-4 area and polar coordinates. Great job with this. Have a super day.